Yes,
Okay.
so good morning to you all. Today we will be dealing with Module 9, that is address resolution. Address resolution, that is MAC and IP address. What is a MAC address? MAC address is a born-in address or a physical address that is usually um, on a NIC card, and it is 48 bits long. Okay, it's hardware address. It's also called the physical address, and the IP address is a logical address that is 32-bit long. Destination on sorry, destination on the same network. Like this diagram you're seeing here is like how does a computer like PCA sends information to PCB when they are all in the same network. If you look at this diagram here, this computer has an IP address. PC1 has an IP address 192.168.10.10, and PC2 has 192.168.10.11. So these two PCs are on the same network, you can see. So how does PC1 send information to PCB? So PC1, this is the IP address. This is the logical address, 192, and it has a MAC address of AA-AA-AA. That is the physical address. So PC1 will send a packet, and that packet is going to have the destination MAC, that is the MAC address of PC2, and the source MAC, that is the MAC address of PC1, and the source IP, that is the IP of PC1, and destination IP, that is the IP of PCB. Okay, so this means that the PC will need both physical and logical IP to be able to send the packet. So in this other example, PC1 and PC2 are on different network. You can see we have router 1 and router 2. I mean, I hope you can hear me well.
Yes, I can.
Okay, in this other example, PC1 and PC2 are on a completely different network. So in this case, when PC1 is sending this information, the moment the computer send that information and realize that the destination, that is PC2, is on a remote network. So the destination MAC address here will not be 55. It is going to be the MAC address of the interface here on router 1. You can see the MAC address on router 1's gigabit 0/0/0 is BBBBB. So that is going to be the MAC address on the packet, and the source MAC address of PC1, and the source MAC address of, and the source IP of PC1, and the destination IP. So that is how it is forwarded. Okay. Okay. All right. So next one is app. What does app stand for? App is Address Resolution Protocol. App stands for Address Resolution Protocol. So an overview of app. A device use app to determine the destination MAC address of a local device when it knows an IP address. Okay, the device is going to use app to find out the destination MAC address when the device already know the IP address. Okay, like I was trying to give you the example. Like if I want to come to your house, I have your mobile number, that is your IP address, but I do not know your physical address, your location. That will be your MAC address. So one thing I can do is I can call you on your phone and tell you to give me your address so that I can come to your house. So the same thing is happening here. This computer knows the IP address of the computer that it wants to talk to, but it needs the MAC address so that they can communicate. So the computer is going to send an app. The app request is going to ask for the MAC address of the computer, okay? So these are the functions of app. The functions of app is if a packet destination IPv4 address is on the same network, the device will search the app table for the device IPv4. If they are on the same network, if both the source and destination are on the same network, the device is going to search the app table for the destinations. But if the destination address is on a different network, the device will going to search the app table for IPv4 address of the default gateway. Like I told you, if the destination is on a different network, you use the MAC address of the default gateway. If the device locates the IP address, its corresponding MAC address is used as the destination MAC address in the frame. If the device locates the address and its corresponding MAC address is used to send the frame. If there is no app table entry found, then the device will search an app request. You will get to see that computers themselves will have an app entry table, so as the routers too. Okay, this is a very short slide. I don't know. Right. Removing entries from the app table. Like we said, computers will maintain an app table and routers will also maintain an app table. So you can remove these entries. It says entries in the app table, they are not permanent because they are stored in the cache. They are not permanent, okay? And they could expire after a specific time period. So the duration of the app cache timer differs depending on the operating system. The duration of which the app table will be maintained will differ from one operating system to another operating system. App table entries can also be removed manually by the administrator. That means the system administrator can go and remove the app table entries, can clear them. App tables on networking device. You can see if you log into your router, this is the command to type to check for your app table. That is show IP app. This is going to give you the app table. You can see in this table, you have one physical address, one logical address, IP address, and this is the MAC address of that device. And it is connected to gigabit 0/0. That is in the routers. So if you go to Windows PC, you go to command prompt, you type app-a will also give you IP addresses and their MAC addresses. Okay. So app issues, app broadcasting and app spoofing. App requests are received and processed by every device on the local network. They are received and processed. Excessive app broadcasts can cause some reduction in performance. Too much of app broadcast in the network can create network congestion. App replies can be spoofed by threat actors. The app reply that the computer will send to give its MAC address can be captured by an attacker and then modified. Enterprise level switch include mitigation techniques to protect against app attacks. So like I told you, it's a very short slide. This is the end of the slide. And for this one, there is no practicals, okay? So we gonna